Hi, everybody. We are from Stanford SILICON. Thank you all for being here. My name is Samantha, and
I'm Daniel.
Diana. We have a third peer, Diana. She'll be coming very soon. And yeah, today we want to present some of the projects that we've been working on. And yeah, I wanted to start out with MILQSHAKE. So as many of you guys know, expanding CLDR coverage comes with no shortage of challenges, especially when it comes to time, effort, money for translation. So at Silicon, we started by asking a very simple question, which is, instead of collecting more data, what if we actually made better use of the data that we already had? And that's where MILQSHAKE comes in. So the beauty of MILQSHAKE, it really lies in its simplicity. Specifically, MILQSHAKE actually requires no new data at all. At its core, MILQSHAKE really takes a second look at large publicly available translation data sets like Meta's No Language Left Behind, Masakane, and more. And while these corpora were originally designed for the purpose of machine translation, they actually really contain hidden gems, specifically CLDR-relevant data waiting to be identified, extracted, and stored. So at Silicon, we really live by the motto, respect the time of the language contributor. And so we really wanted to, before asking language communities to contribute more data, we wanted to make sure that we were really making use of the data that we already had. So by reimagining and repurposing existing resources, we shake out every hidden insight and collect every valuable crumb. So MILQSHAKE is a custom NLP extraction tool that finds those hidden gems that we talked about, automatically identifying CLDR-relevant vocabulary, predicting translations, and then storing them for later validation by language contributors. So rather than having the contributors build a whole data set from scratch, MILQSHAKE gets us most of the way there. That means language contributors no longer have to start with a completely blank slate. They can simply validate translations instead of creating the whole thing from the ground up. In other words, MILQSHAKE doesn't, replace human expertise, but it amplifies it. It expedites the process, turning the hardest part of data creation into a much lighter, faster process. So we've seen this. So let's see a little bit of MILQSHAKE actually in action. So when users arrive, they're greeted by a very clean, intuitive interface where they can select their target language and the elements they want to extract. So extraction elements include months, days of the week, or time-related categories. We actually also have other option where users can define their own regex patterns to capture any vocabulary that they choose. So after selecting a script type and uploading their parallel corpora, MILQSHAKE takes over, running the data through its powerful extraction pipeline. So that was kind of a broad overview of the general flow, but let's take a closer look at what that pipeline actually looks like. So to start, a user uploads a parallel corpus. We can say, for example, that they upload, English and German. MILQSHAKE begins by scanning this corpus line for line, filtering any sentences that might contain useful data. So in this example, MILQSHAKE identifies the following pair of sentences because it contains the word Monday, which is relevant for CLDR calendar data. So in German, this might be easy to identify, but with digitally disadvantaged languages, that might turn to be much more complex. So to help find the answer of really which word in here is Monday, MILQSHAKE employs context-aware zero-shot learning. So instead of relying on pre-existing labels or manual training data, the model uses context and reasoning to infer the correct translation on its own. For example, in this case, let's say that CLDR doesn't have the stored translation for Monday, but it may already know, for instance, the word for day, Tag. Armed with that clue, MILQSHAKE can use morphological and contextual hints to recognize that Montag, I don't know if I'm pronouncing that right, which literally contains the word Tag, is likely to be the German equivalent for Monday. So it's not just looking at words in isolation, it's reasoning through relationships and structures in context. So once the model extracts its predicted translation, it adds it to this growing list of, predicted translations. And this process repeats itself for all of the relevant sentence pairs across the corpus. After collecting those many predictions, MILQSHAKE performs a sort of statistical analysis to determine which translation appears most consistently. For instance, there might be some noise, but if 90% of the sentences extracted Montag, MILQSHAKE concludes that Montag is the best translation, while keeping a record of some others as potential variants. And we'll see those variants soon. So MILQSHAKE's output is a ready-to-use CSV containing the term's most likely translation, the frequency of that translation, and any alternative variants. This CSV can be easily downloaded, exported, and applied, supporting research, teaching, and hopefully further linguistic validation. So before we wrap up here, I want to actually highlight the significance of those variants. So at first, the variants were frustrating. We felt that they were actually noise, cases where MILQSHAKE had simply guessed inconsistently. But over time, we realized that these differences actually tell a deeper story about the language itself. Sometimes variants reflect regional or dialectal differences, showing how speakers in different areas truly use the language. Other times, there are orthographic differences like capitalization, spelling, hyphenation, diacritics. But we saw that even within a single corpus, the same word might appear spelled 2, 3, even 4 different times, which is actually a valuable insight to have. And so while that seemed like a problem at first, it actually really became a strength of MILQSHAKE. So rather than forcing all the translations into one standardized form, MILQSHAKE really preserves that diversity. It doesn't capture a single answer, it captures the range of real-world expressions. In that way, it becomes not just a data extraction tool, but really a window into linguistic variation. So MILQSHAKE is actually already showing a lot of great promise, outperforming other models on key tasks. So as shown here, for extracting months or days of the week, MILQSHAKE achieves approximately 150% of the accuracy of Meta's No Language Left Behind model, which was actually trained on a lot of the data that we're using. We do find that MILQSHAKE tends to perform especially well on Latin-based scripts, but that's something that we really hope to extend in future iterations is, adjusting it to cover non-Latin-based scripts. So MILQSHAKE is actually already fully up and running. You can find it at milkshake.com. So we hope that MILQSHAKE can actually really grow beyond Silicon itself, partnering with communities, nonprofits, and tech organizations. Really, MILQSHAKE can turn discarded data into opportunity, laying the groundwork for a more complete, connected, and equitable digital world. Thank you. And now we'll hear from Daniel.
All right, hello everyone. You guys hear me all right? Yes. All right, fantastic. Thank you for the introduction, Samantha. To reintroduce myself, I'm Daniel. I'm a sophomore at Stanford, and this summer I had the pleasure of working with both Unicode and Silicon on this project that I created, LexRay. It's a tool that's built to make one part of the process of data contribution more seamless, interactive, and educational. So as I'm sure we all already have today, you open up your phone and you see today's date, November 12th. But I want you to imagine that your native language isn't English and perhaps you're not in the US. You might see something of the effect like 12 de noviembre if your native language is Spanish. It's a different words, different order, but has the same meaning. And we all know that is thanks to Unicode's Common Locale Data Repository, or CLDR. This is really the language repository responsible and underpinning the digital localization efforts worldwide. I want to take a step back before jumping into the specifics of LexRay to give a bit of context. So out of the 7,000 world languages, 98% of them are considered digitally disadvantaged languages, meaning that they lack technological infrastructure like keyboards, fonts, and parallel corpora and the like. So when a language enters the CLDR, it represents so much more than just technical progress. It's about laying the conditions of possibility out for a language to be included in the digital world. And as we know all too well, preparing a language for digital representation involves so much more than just scraping language translations from the internet. It requires significant effort, as Samantha highlighted. It's about encoding how a language structures information, so things like time formats, date formats, numbering rules, and plural forms. I want to take a canonical example on the CLDR of September 5th. So to capture that in the CLDR as a refresher, it must be encoded as something like a lowercase d, followed by the literal word day and 4 capital M's. And so this is basically telling your computer, hey, I want you to put the day first, then the literal string day, followed by the full length form of the month. That translation from natural language to CLDR skeleton code can be one hurdle that language communities face in the process of data contribution. It requires a level of technical familiarity or knowledge that understandably many language contributors do not have. But that's where LexRay comes in. LexRay aids in this mapping process from natural language to CLDR skeletons, really enabling language communities to focus more on natural language and language meaning and less so on the technical syntax. Instead of learning to format their language data, contributors can simply enter the natural language expression in their language, like 12 de noviembre, and LexRay will convert that into the CLDR skeleton code. And so the idea is relatively simple. It's about making contribution more intuitive and scalable. Here's a high-level overview of the workflow. So contributors provide a list of English expressions. So for example, November 12th, followed by their adjacent Spanish translations or target language translations. LexRay then parses both sides, both the English original and the target language expression, detects any patterns, and then outputs the proper CLDR skeleton code. The beauty of this is that it can handle more than just one input at a time. It can really work in batches. So instead of processing one example per minute, you can process multiple examples at a given time. Embedded in the LexRay interface are two options. One is for single item processing. So this is rapid iteration and validation, similar to you saw on the previous slide of a single expression you're interested in getting the skeleton for. But likely more applicable to our context of adding a new language's data in aggregate would be the batch processing feature. To double click more into the batch processing network, the contributor is asked to upload two CSV files. The first is what I call like a quasi-lexicon of sorts, where they're asked to contribute some very small subset of the target language's lexicon, namely the days of the week, or names for days of the week and months of the years. As you see here, the translations in Spanish for months of the year. Secondly, they must upload parallel corpora, so a list of English expressions as well as their parallel target language expressions. And then once they press process batch on the LexRay interface, then they're outputted the CLDR skeletons in the target language, along with their XPath, which is an identifiable code that makes data ingestion into the CLDR seamless. To get a bit more into the specifics, LexRay uses a regex-based tokenization system as well as cross-validation referencing with validated CLDR data. For example, if the input was November 12th, going back to that example, it would pair November with Noviembre and identify those as full-length month forms. It would look at 12, identifying that as a day, and map that to 12 in Spanish. And then it would look at day, the word day in Spanish, and identify that as not being a word that was included in the uploaded quasi-lexicon, and realize that's a string literal. So it will place that in single quotations per the standards set out by Unicode and the CLDR. So this alignment-based logic in mapping allows it to infer structural patterns for languages that are not even in the CLDR yet. Now that I've gone into a bit of the specifics of the LexRay program, I want to take a step back and transition into speaking about overall themes and use cases for LexRay. First, I want to start out that the goal is to empower contributors and to make contribution to the CLDR more accessible and to allow more communities to participate confidently. That's goal number one. Each new language represented in the CLDR ultimately does bring its speakers closer to the digital inclusion world, where they can not only see but use their language in their own, use technology in their own terms. As I mentioned previously in my introduction, LexRay can also function as an educational tool. It's a part of a broader planned initiative called CLDR Academy, which we foresee as an online hub for resources, toolkits, as well as sandbox environments where language contributors can learn best practices and the mechanics behind contributing to Unicode systems. Together, CLDR Academy and LexRay can form an interoperable system. LexRay, our CLDR Academy allowing for training of contributors and LexRay allowing them to act. Right now, LexRay is really good at handling date patterns, so things like days, months, and years, but there's a total array of different possibilities for where it could head next. One particular example I will provide is times and time formatting. So time formats vary across different languages, right? We have 12-hour formatting, we have 24-hour formatting, we have punctuation differences across different languages, as well as different suffixes that are used. So an AM, PM versus a system versus, maybe the suffix sward. Future iterations could extend also to number systems, time zones, and plural rules. I want to conclude by saying that this project really advances both Unicode's and Silicon's shared mission, which is to make digital infrastructure multilingual by design. Within Silicon, we've recently been collaborating with over 100 languages to aid in their contribution to the CLDR. And by virtue of that has required internal tooling, and LexRay emerged as a direct need of that. LexRay shows that inclusion doesn't have to mean complexity. Smart tooling can really bring more voices into Unicode's global digital infrastructure while ensuring that human insight is maintained and that makes linguistic data super meaningful to us. For me, the most rewarding part about working on LexRay was thinking through how tools like these can really reshape participation. So when communities can engage in language inclusion and digital inclusion without needing to take an active role in the repackaging of their language for data purposes, that really changes the dynamic. And so every skeleton generated by LexRay, be it by hand or through every skeleton generated, be it through LexRay or by hand, represents really more than just a code. It's a tangible mark. It's a tangible mark of a language's presence online. So to recap, LexRay assists in the mapping process between natural language and CLDR skeletons. Secondly, by extension of that, it addresses one hurdle that language communities face in the process of data contribution. And lastly, it advances Unicode's and Silicon's shared mission, which is to make digital infrastructure more interoperable, more inclusive, and lastly, more multilingual by design. So if there's one takeaway, it's that digital inclusion efforts can start small, something as simple as a date, but those small steps can really build up in an aggregate that can affect how millions of people experience the internet. All right, with that, I'll pass it back to Samantha for her coverage of QSAS.
Hello, I'm back. Great. Okay, so now we're going to transfer a little bit to talking about keyboard design. So I want to mention for this project, I was able to build upon the great work of the QSAS lead researcher this past summer, Aaron Dye. So at its core, QSAS addresses a critical challenge that I'm sure we'll hear about in other presentations, which is keyboard creation, making it possible for language communities to build functional keyboards for their own language without relying too much on outside experts. So as we know, creating a keyboard requires not just two elements, but two elements, which is a character set, the letters, symbols, glyphs a language uses, as well as kind of a formatting or layout, so the arrangement of those letters on the keyboard. And QSAS really works to simplify this process, making it easy and fast, intuitive, accessible, It allows language communities to create their own custom keyboards without needing extensive technical knowledge or external support, enabling them to really have agency in their digital presence. So Keysos works in 3 main stages. It extracts the unique character set from a language. It identifies existing keyboards that can serve as starting points, and then it enables customization through a 3D visualizer. So each step really builds upon the previous one to ensure that communities start with a solid foundation and can finish with a more functional, usable keyboard that they design themselves. So step 1 is extracting a unique character set. So users start by inserting a sample text from their language, or we can use, a corpus that's already out there. It identifies all the unique characters while also filtering out symbols or other noise that might be in that data set if it's there. We found that using data sets like Meta's No Language Left Behind, Keysos can actually identify on average 99% of main letters and 98% of index letters documented in Unicode CLDR. So this high accuracy means that Keysos captures nearly all the essential elements of a language's written system with really minimum manual effort, providing a reliable foundation for a functional keyboard. So communities don't need to worry as much about missing characters. And so that reduces the risk of incomplete keyboards and lets them really focus a lot of their attention on layout and customization instead of just basic level coverage. Step 2 is to identify relevant existing keyboards. So that's really important because it helps to limit or mitigate the blank page problem. So with Keysos, we automatically compare it to basically a database of 200 plus Microsoft existing keyboard layouts from around the world. And by doing this, Keysos really suggests a practical starting point, giving communities a real world example of where their keyboard might start. So really, once they input the character set, it ranks the top 10 matches using 2 key metrics, and that is coverage and overlap. So coverage really says how much of the language's characters are already supported in this existing keyboard. And in other words, of all the characters in the set, how many are on the keyboard already? They don't need to, modify it. And overlap says how much of the existing layout on this keyboard is actually useful for the language contributor. That is, of the characters on the keyboard, how many belong to the language and would likely be kept. So by quantifying both coverage and overlap, Keysos really solves this blank page problem. The challenge of starting a keyboard from scratch can be very daunting and require some real technical knowledge. So communities can get a data-driven foundation that guides their design decisions and reduces unnecessary trial and error. And finally, step 3 allows for customization with a 3D visualizer. So in this final step, Keysos allows users to fully customize their keyboard using a 3D visualizer built on contributors from Carson Britt and other GitHub collaborators. This visualizer functions as an interactive keyboard simulator, giving users real-time hands-on view of the proposed layout. So we can see that users can view the layouts in different sizes and shapes to match the target device. So that could be full-size keyboards or compact mobile designs. Users can also switch between recommended layouts or legends and test alternative layouts or propose their own custom sub-legend. And finally, this 3D designer allows users to edit any key instantly, adding new characters, removing ones that aren't needed, or repositioning keys to better match the language. So as soon as a change is made, it's immediately reflected in the 3D model and updated in real time. This instant feedback allows for a more rapid iteration. Users can try different arrangements, test usability, and fine-tune the keyboard without waiting for static previews or repeated exports. It also really encourages a lot of experimentation, helping communities optimize the layout for speed, ergonomics, and ease of use. ensuring the final keyboard is both functional and comfortable for native speakers and really feels like it's theirs. So therefore, QZOS is a complete end-to-end pipeline. It takes the language's main text and delivers a character set. It also delivers data-driven starting points for the language contributor, and finally, a fully customizable keyboard. Language communities no longer need to wait for funding or outside experts to begin their digital journey. And now also fully up and running, QZOS gives them the tools to start immediately, enabling a faster, more inclusive, and more autonomous creation of digital keyboards. Thank you. And now I'll pass it to Diana, who's going to talk about emojis.
Yeah, okay, awesome. All right. Okay. Emojis are a powerful way to communicate with each other, helping us express emotions and ideas beyond words. But their meanings aren't always universal, as they can shift from language, culture, or generation. Take the laughing, crying emoji. Some see it as deep sadness, while others use it to mean uncontrollable laughter. So how do we capture and understand these differences? The key to language realization and engagement in the 21st century is getting young people involved. Emojis are perfect for this, as they're one of the most useful and dynamic components that come from the CLDR. Of course, emojis aren't just for young people. Because they represent emotions and shared human experiences, they transcend age and language barriers. Returning to the question, how do we capture and understand differences in emoji communication across languages and generations? We first need to recognize two main challenges. First, emoji communication isn't something one person can define. It requires a collective effort. People within the community must agree on what emojis represent. And this needs to engage not just one language group, but a diversity of voices, young and old, urban and rural, across socioeconomic and cultural factors. Second, most digitally disadvantaged languages don't have equal access to the modern sections of the CLDR, where emojis live. This widens the gap in digital representation and inclusion, leaving many communities without a voice in how emojis and digital symbols reflect their experiences. So we asked ourselves, what's something that could bring people together to collaborate, something fun, engaging, and meaningful? Well, that's where QMoji comes in. The Stanford SILICON designed and created on QMoji, a fun multiplayer board game that converts emoji communication with collaboration. On the surface, it may seem like a lighthearted game, but underneath, it's a powerful tool. As players describe emojis in their own words, their responses are recorded, building a data set of how different groups interpret meaning. In the process, the players are just having fun, they're contributing critical linguistic data that supports digital inclusion, while developing a sense of ownership and pride in their language. Our first version, which we actually have here, was inspired by the board game Q's and Q's. So as you can see, there's a lot of emojis on there, I think 416 to be exact. But this was our first iteration, and we essentially, again, took inspiration from Q's and Q's, where players describe colors without using obvious color names. We swapped colors for emojis, arranging again 416 emojis grouped by theme. Players would draw a card, choose one of the 4 emojis on there, and give a 1 to 2 word clue for others to guess. These short clues became valuable linguistic data, keywords that tell us how people describe emotions and concepts visually. We also added wild cards, so players would have to act out their emoji, like pretending to be a cyclone or a chair, making the game more enjoyable and fun, because again, we want to make sure that we can balance collecting data, but also making it a fun board game for people to enjoy. So again, like there's 460 emojis, and grouping them by close proximity and theme was very difficult. So that challenge us to rethink our approach. Our latest design draws inspiration from Candyland. So this is our second iteration. Here we go. And it is it uses a dice-based movement system where players roll a dice to move across the board. And depending on where they land, they might get a normal space. So that's any of the colored spaces, an acted out space for emoji charades, a lightning round, which is essentially just a shortcut to get further closer to the end, and a swap space where they trade positions with another player. So the player in first place can swap positions with the person in last place. On every turn, the player also flips an emoji card, and everyone has 20 seconds to write as many descriptive words as they can. And at the end, everyone reveals your notes, and shared words let players move extra spaces forward. These shared words let players are important because some of them would directly align with some of our keywords, meaning we're generating live data that mirrors real linguistic use. And like I said, this mechanism was really important for us because they are reflecting words that are found in the CLDR keyword list. And while we're collecting data, we're also ensuring that the actual experience of playing the game is fun. And so, so to see whether or not the game actually worked as we had intended, we held our first play testing event on campus. We had Thai food, my favorite. We printed out basic instructions for people, but we also encouraged flexibility so that players could bend the rules and make it more fun, depending on what they felt was right. And we did. The room was full of laughter, and that is exactly what we essentially wanted to make this a fun board game. Some of the feedback we received, a lot of players found that the board layout was hard to follow. It's really S shape, so it was a bit hard to follow. So we redesigned it for clarity, and so this is our redesigned board. So instead of kind of the shifter ladders format, we now have like our beautiful emoji, and we start off here, go around the circle, and so that is our newest latest design. And so yeah, so another piece of feedback we received is, sometimes some players that were a bit behind found it a bit hard to catch up to players that were a bit further ahead. So then they lost a little bit of engagement there. But essentially with this board game, we're balancing two goals. One, collecting meaningful data, and collecting meaningful data, and two, creating a well-designed game that feels fair, fast-paced, and fun. And this is some of the data that we found that when users had to write down words that they would have to describe the emoji with, a lot of the words, sometimes players would have no words that they had shared in common with other players. Other instances, all the words that they had written down were shared with other players. And so it's really interesting to see what words we use to describe emojis, because there are some differences in how people interpret them. And so, yeah, this is just like one of the sheets that we received from the playtesting event. And so, and again, this is our newest design. So overall, what QMoji teaches us is that collaboration can be used to turn a simple game into a bridge for digital inclusion. Through play, people aren't just enjoying themselves or helping build a more representative digital world. More communities whose languages are often left out, I can see their linguistic and cultural expressions reflected online. And looking forward, we continue to iterate. We're refining the gameplay, more logic, and more ways to integrate the data we collect into broader digital language initiative. And if you have to take anything away from this presentation, let it be this. Machine learning inclusivity cannot be done without the participation of the language communities themselves. And we believe that QMoji is a step for that small but joyful experiment in making inclusive and collaborative, creative, fun. And this is not the end of QMoji's journey, it's just the beginning. So if any of this sparked your curiosity or ideas, please feel free to chat afterwards. And I believe this is the end of our presentation. So yeah, we'll take any questions that you may have.
Ooh.
Hey, first of all, cool that we have some representation from Stanford. My name is Yu. I'm actually representing, I came from Boston University for undergrad. So shout out Boston, because I know, I think over at Harvard and MIT, I did a laboratory over there. I think they do work with Stanford. So it's pretty sick. But I'm here now. I'm actually with the Middlebury Institute, and I kind of attest to a lot of the issues that you guys had encountered in the projects that you had described, because we have a meta lab here at the Institute, and we are currently working on a translation management software. And one of the challenges, especially with textual corpora in the context of digitally disadvantaged and also low representation languages, is the idea of a data or repository to be able to store this vast amount and also very useful or resourceful information that you guys collect. And whether it's a game night or multiple game nights, or whether it's right in the laboratory, because I know you guys work at Silicon. I bet that you guys work with a lot, and you kind of wonder, instead of using, CLDR, for instance, or, working with other laboratories or other repositories is like a, not necessarily so, but in partnership and collaborative, to effectuate a collaborative paradigm where you guys can combine data and make it useful. I wonder if either at Silicon or Extra Silicon, you guys have considered formulating your own repository, for linguistic heavy, institutions. I know that this is commonplace, like UMass Amherst or Harvard, but I was wondering if Stanford has something going on like that right now, or are they looking to institute something like that in the future? What kind of is the plan?
Thank you. Oh, do you want to answer? Okay. Yeah, thank you for the question. Thank you for coming. And Boston is great. Yes. Yeah, so that's a great question. We haven't implemented our own repository yet, mostly because we're really committed to contributing to CLDR. But one idea that we have been floating around is taking care of the language communities that want their languages documented but aren't quite ready to share their information with CLDR. And that is something that we're thinking about, is kind of creating that repository to document languages without breaching that privacy, because I think you might mention this, like languages are intellectual property. And so we really want people to be able to document their languages for those purposes without, even if they don't necessarily want to share it yet. But we haven't created our own repository yet. I'd love to talk too about that. Yeah. Anything to add?
So I was just curious, a lot of this stuff is based on parallel corpora, which I think is really great. And a lot of the research that I do for contributing to CLDR and SIL's version of CLDR, SLDR involves a lot of me referencing parallel corpora. I was wondering, a lot of languages do not have a lot of parallel corpora in English. They might, if it's based in Latin America, they might have a ton of parallel corpora in Spanish. If it's in Francophone Africa, it might be a ton in French. Are there plans to include, to eventually expand to include other languages as the majority language parallel corpora eventually?
I can speak in the context of LexRay. So currently LexRay is built where the source language is English, but we definitely want to expand it to include other languages. And the first languages that we'd be likely to include are the ones that already exist within the CLDR. Because LexRay is specifically focused on date expressions like days of the week, months of the year, and because that information is already readily available in the CLDR for a vast number of languages, that's definitely an area of possibility for expansion.
Yeah, and with regards to MILQSHAKE, absolutely. It was because it was just created this summer, we kind of started with English, but that is something that I noticed when I was going through it, especially with like a lot of African languages. The parallel corpora was with French. And so, yes, to give you that answer, yeah.
I'll be brief because it's lunch.
Yeah.
So your tools, are you trying to get them closer to CLDR? Maybe like include them with the CLDR project, or are they going to be completely separate but contributing to CLDR?
You want to start?
Sure. Start us off. So to speak a little bit to my efforts, to the efforts of Silicon in recent times, as I mentioned, we're collaborating with over 100 different language communities and their focus right now is, providing us the relevant data that can be contributed directly to the CLDR. And so in terms of, but a lot of the tools that we built out or have presented today are internal tooling for Silicon that we work in collaboration with Unicode. But we definitely, in the weeks and months and in years to come, we definitely want to keep the synergies with Unicode and find possibilities where we can kind of sort of implement our systems in tandem with the CLDR.
Yeah, for MILQSHAKE, I would say definitely we're looking to kind of partner with any organization that might find the tool useful, whether that's a big tech company or CLDR. We definitely want to get this tools in the hands with the idea that it is not perfect and it will need validation and it will need, direct confirmation from the language communities. Yeah, I know we're at time, but
Yeah, we're actually at time. Is that okay, Adele?
but we would
Okay.
love to talk afterward.
Yeah, you can talk afterward. Lunch is now going to be served down at the end of the hall. Please get there before the students descend. And go Cardinals.